All right, guys. Sorry I'm not there today. Just walking through the worksheet. This is a review of what we've done so far, so this should be a review for you guys. So we're doing just a lateral area and surface area review. So let's just go through the shapes. I'll walk you through the formulas. We'll talk about the certain properties here and what we're looking for each shape to figure this out. So first shape here is a triangular prism. Okay, so remember prisms for lateral area have the formula of the perimeter of the base times the height. Okay, and the surface area is the lateral area, whatever that is, plus 2 times the area of the base. And this formula 2b here is going to change depending on the shape. Okay, so let's go back to lateral area for a second. So the perimeter of the base, so remember the base is a triangle, so it has sides of 3, 4, and 5. So the perimeter is 3 plus 4 plus 5. Now, if you know that that's just 12, just put 12 and that's fine. All right, I want to show you guys where it comes from. And then the height of the prism here is this side, which is 6. Okay, so we get this 6. And I'm using little styles here, so it's not the greatest, but it's working for right now. And you should be able to figure out what that is. So we're going to calculate the surface area, and that's equal to that number we get, so just put that down there for yourself, plus 2 times, and this base, right, is a triangle, so the area is 1/2 the area, the base of the triangle times the height of the triangle. So don't be caught up in those h's, don't remember what they mean. So really this 2.5 is going to cancel out. And when we think about the triangle here, okay, remember that this is the base of the triangle and this is the height. It's a right triangle, so the legs, right? There's our base, okay, there's our height. Remember the legs of the triangle, the base and the height. So you're just going to plug that in for B and H there. Okay, so it's really the lateral area, which I think is 72 when you get down to it, plus that extra 3 times 4. Okay, next shape is a rectangular prism. We're going to use this side as our base right here. Okay, so that's our base. You should know that. We have to tell you what the base is before we begin. Change the base could change the lateral area. Surface area will stay the same. So remember, lateral area is perimeter of the base times the height. So for that base, remember there's sides of 2. So there's 2 sides of 2. So 2 times 2 plus 2 times 3. 2 sides of 3. So 2, 2, 3, 3, right? All right, and then times the height of the prism, which is that guy right there, so times 5. And then the surface area, if you remember, is the lateral area, which is just going to come from there, plus 2 times the area of the base. And then we have to change that formula. So you're going to input that number here you get from up top, and then it's 2 times, remember that, and this is basically like length times width here, okay? So if you look back, right, the length is that 2, and the width is the 3 from, what happened there? From the other side up here, okay? So you're just going to plug those in and then calculate the math, okay? So figure out what that is. All right. So cones, okay, cones once again. So I'm looking at my cone. The cone has a height which runs perpendicular. This is called a right cone because the height is directly above the center of the cone. And then this side over here is referred to as our slant height. That gets that lowercase cursive L. Okay. Now, if you remember, the lateral area has a special formula here. It's pi r and then L. Pi r L. Remember, it's really 1/2 PL, right? 1/2 PL. But the perimeter is 2 pi r, and the 1/2 are going to cancel out. This is where that special formula comes from. And then the surface area formula is the lateral area that we just talked about above, plus the area of the base, which is always a circle, so it's just pi r squared. Okay, so we know the radius is half of that diameter there, which is 8. So this should just be pi times 4 times our slant height of 8. All right, and I prefer to use parentheses instead of the dots. Just keep track of the negatives too. All right, so that answer is going to go in there. And then this is this plus, and this should just be 4 squared. And then just remember, in terms of pi, or are you rounding? So make sure you check that answer for yourself. Okay, cylinders. So our base is a circle. So there is a special formula for the lateral area, right, which is the circumference times the height. So 2 pi r h, okay? Remember, pi r squared, radius squared, like unit squared, okay, versus the capital, the big 2 capital 2, right? Yeah, there we go. So the lateral area is 2 pi. Remember that radius there is half of that, so 5 times h, which is the height of the cylinder, and that's that side, so 9. 9. Yeah, that looks great. All right. Surface area, remember, is the lateral area, which we just calculated. So pi r h, okay, plus, and then 2 times the area of the base. And the area of the base is a circle, so 2 pi r squared. All right, and then you're just going to plug that 5 in here for the radius again. And you should be able to do the math there. All right, I'm leaving you guys to finish that up. Okay, on the next page here, a little bit trickier here. So this is a triangular prism. So the base here is this triangular region in the back. Remember, the bases are parallel and congruent. All right, so the lateral area is pretty easy. Perimeter of the base times the height. So remember, it's just the two sides of 3, so 3 times 2, and then times that height, which is running there, okay? So times 7, and that's your lateral area, all right? And you guys can calculate that one out. The surface area gets a little bit more tricky, okay? It's the lateral area, we already know that, okay? Plus 2 times the area of the base. So this is going to be that answer we get from up there, plus 2 times 1/2 times the base times the height of our triangle. Now the base is nice and easy. It's that side right there, okay? The height gets a little more difficult, so I'm just going to redraw. So let me get rid of this guy for now, just so I have some room. Make that go away. Get out of there, you. All right. All right, let's get a triangle in here. So I got this triangle. Now, what do we know about the triangle? We know a few things, right? Number one, we know that all the sides are 2, so we know it's equilateral. And that means that each of these angles is 60 degrees. So when I drop an altitude, or the height, from the top here, I know that this is going to create a 30, 60, 90 degree right triangle. If you remember, that means my sides are x across from the smallest angle, 2x across from the biggest angle, and then x times the square root of 3 across from the 60 degree angle, longer leg. So I have sides of 2, of 1, and of 1 radical 3. So that means my height is essentially radical 3 here, right? The square root of 3. That's what the height is. So a little bit more work. Just going to drop that in. So we already know the lateral area. That was from up here, right? Essentially 42, 6 times 7, plus, and then the 2 and the 1/2, remember, are actually going to cancel here. So these are going to go away. So if you want to drop them out early and to write them, it's up to you. The base of our triangle is that 2, so plus 2 times the height, which is radical 3. And then you're rounding that out, I believe, right? If we're continuing on from the last page, you're rounding that one out and you should be good to go. All right, number 6. So remember, this is our slant height, okay? And then the actual height of the pyramid, if we need it, is going to drop right down the middle there. Okay? Now remember the formula here for the lateral area for a pyramid is 1/2 the perimeter of the base times the slant height, 1/2 PL. So 2 bases, right, is perimeter of the base times the height of the prism. 1 base is 1/2 PL. And then for this, the cone, it's just pi RL, really. So this is 1/2. Now this perimeter of the base is essentially a square, so it's going to have sides of 12. So that's sides of 12, and there's 4 of them, times the slant height, which is 8. And then you're going to calculate that out here, okay? The surface area, remember, is the lateral area plus the area of the base, and remember that base is a square, so this formula, right, is really just length times width. So the surface area is that number we got there, plus, and then 12 times 12. Just cleaning that up because that 12 is pretty gnarly there. All right. And then you're going to identify what that surface area is there. Okay. Jumping down, find the missing heights. Remember, when we're doing this, we want to think about taking the shape and looking at it two ways. Okay. The first way is when the shape is sitting like this. And so I have a base this way, right? And a height that drops over here. Or I could lay the figure this way, right? And I could have a base down here, okay? And then a height that drops this way. So if this is sitting up, this is 10 and this is 8. All right, if that's standing on the tall end. And then if this is laying on this long side, this is 20 and this is h. And so I know that if I calculate the area here, which is 8 times 10, so that's 80, that area has to be the same as 20 times h. So if 80 equals 20h, then what's h? Same thing here, okay? So I want you to do the same thing for b, and you guys should be able to figure that one out. I'm jumping to the next page here, guys. Number 10. Maybe. Oh, look at that. Get out of there, you. As you're all pausing and are finishing. But we're going to go through it. All right. So food company makes a regular tall soup cans. The area of the base of the tall soup can is 25 pi centimeters squared. The surface area of the regular can is 170 pi centimeters squared. The tall can is 5 centimeters taller. What's the surface area of the tall soup can to the nearest thousandth? So a lot going on here. Let's go back to the question though. We want to know the surface area of a tall soup can. Let's just draw our two cans. So we got, and then I don't mean the birds. Jokes, guys. All right. I got this can over here. All right. And I know that this is the tall guy, and then we'll do a short one here. All right. Yeah, you go away. All right. So we know the tall can is 5 centimeters taller. So if this is h for the height here, then this is essentially h plus 5. That's 5 centimeters taller. All right, we know the area of the base of the tall soup can, so the area here is equal to 25 pi centimeters squared. And we know the surface area of the regular can, okay, so the surface area is 170 pi. You're really not going to move for me? Okay. So first of all, what I need to do is use this and figure out r, and then use this and figure out h. And once I have those two things, then I can do the surface area. Okay? So let's go back to the first step. First, I got to figure out the radius. So I know the area of my circle on the bottom is 25 pi. The area is pi r squared, because it's a circle. So 25 pi is equal to pi r squared. So I need to get rid of the pi first. Remember, do not take the square root until the squared term, r squared, is by itself. Okay, if there's something next to it, you need to get rid of it first. If you square root pi r squared, okay, this does not equal pi r, okay? What it equals is the square root of pi times r. And now I have to deal with this ugly thing, which I don't know about you, but I don't want to take the square root of pi, okay? What if it's another number, like 2 or something crazy? Don't want to do that. So I'm going to get rid of the pi's first. Now there's pi's on both sides. If you forget the pi's on both sides, this number is going to be ugly. Okay? This comes out nice. So this is just equal to pi r squared. And now I can take the square root and just get 5 for the radius. Okay, second part. We need the height. So the surface area of this thing is 2 pi r h plus 2 pi r squared. All right, and we're just going to plug in. All right. Now, it says the area of the soup cans, it should be both cans, is the same. So the only difference is the height here. So the surface area is 2, that should be a 2. 2 pi times 5. Oh, and you know what we forgot? Instead of writing SA, we're going to fill in what it is. So that's 170 pi is equal to 2 pi, right, times 5 times h, because we don't know it, plus 2 times 5 squared. And really, we should already know that this is 50 because it already told us that. Or sorry, no, the 25 pi was one base, so both should be 50 pi. So keep that in mind. So 170 pi is equal to, now we can combine like terms here. So this has a variable right here. So this is one term, that's another term, okay? So we're going to combine like terms. So 2 times 5 times pi times h is 10 pi h. That's the first term, okay? Plus the second term, which is 25 times 2, that's 50 pi. So my job is to solve for h here. So first thing I need to do is get rid of the 50 pi. I cannot combine these two things together. One has an h and one does not. So I'm going to subtract 50 pi from both sides. I can subtract these because they both have a pi. All right. So this is 10 pi h on the right, and then 120 pi on the left. And then I'm going to divide by 10 pi. Pi's are going to cancel here. And I get 12 equals h. So if this was 12, that means this is now 17. And that I can now tell you the surface area of the big can, okay, because I know the formula, 2 pi rh plus 2 pi r squared. So 2 pi, and it says nearest 10,000, so we're going to round it out. So remember, r is 5, h is 12. Nope, don't do that. Don't do that. 17, people. It's that new height we got here. Plus 2 pi times 5 squared. And I'm going to leave you guys to come up with that answer. All right. Practice, practice. Wow. Volume of a, I feel like I passed one, plastic storage box in the shape of rectangular prism. So, boom, 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 boom. Yeah. There we go. You like the sound effects, admit it. All right. Has a length of x plus 3, a width of x minus 4, and a height of 5. Represent the surface area of the box as a trinomial in terms of x. So this just means it's going to end up being something like x squared plus, right, bx plus c. That's what it should look like when we're done. All right. So remember, surface area is the perimeter of the base times the height plus 2 times the area of the base. So the perimeter of the base is this x minus 4, okay, times x plus 3, and there's 2 of those. So it's really 2 times x minus 4 plus, okay, 2 times x minus plus, sorry, 3. And then that whole thing. So just real quick, I just want to make a slight change here, just so it's easier for you guys to follow, okay? I'll go back to this. I'm going to use a bracket just so we can catch that, okay? Times the height, which we know is 5, plus 2 times the area of the base. And this, we're going to bracket it again. Oh, I don't know what's going on there. All right, bracket again is x minus 4 times x plus 3. So we're going to have to do some distributing here. So this should be pretty easy. We can distribute the 2 through and then combine like terms here. So this is 2x minus 8 plus 2x plus 6, that guy, times 5, plus 2 times, and when we distribute, remember we're doing first, outer, inner, last, we're just doing a rainbow. So x times x, right? X times 3, negative 4 times x, and then negative 4 times 3. And then we'll continue to combine like terms. So this is going to be 4x minus 2 times 5 plus 2 times, bracket, right? And this is x squared minus x minus 12. This is as far as I'm going to take it, guys. Combine like terms and then get your answer. And leave it in, remember, square term first, then the x, and then single number at the end. All right. 12, volume of the sphere. So we haven't done this one yet. So let's do, instead of volume, let's do surface area here. Okay. So the surface area of a sphere is approximately that. All right. So, and this should be square centimeters. All right, so surface area is 4 pi r squared. So this 44.6022 is going to go in for SA, and then 4 pi r squared goes over here. So we're going to divide by 4 pi, and this number, whatever we come up with, I'm not even going to do it. We are just going to take this 44.6022, all right, get that 6 up there, and we're going to divide it by 4 pi, and then immediately after that, we're just going to square root whatever we get for that answer. You can type this whole thing right in your calculator, okay? And that's going to come out to r, and we're going to round it. All right, that's it. On to the next one. Explain what a regular pyramid is. So a regular pyramid has a square base. Actually, it doesn't have to be a square. So let's get that out of there. Don't do that. That means that the shape of the base has to be a regular polygon. So the base is a regular polygon, okay? And think about it for a second, right? Regular. So let's think about let's think about a square, right? Because it's easy to consider. So if this is our base, this is square, we put a dot on the top and we connect this here. I could instead, right? Instead of having that height, what if my dot was up here? And these were my sides now, right? So the height on this could change, okay? So a common misconception is that they want to say that if it's a regular pyramid, they think everything's the same. Only the sides and the base are the same. The other thing that's the same is these two sides have to be equal. All right, and actually these, that, and that have to be equal. So all of these edges here are the same length, which makes this triangle right here isosceles. It's not equilateral because of what we just mentioned before. I can actually put the height here, and now I'm going to have a side length that looks like this. And these two sides, right, are definitely not the same as that base. So it's a regular polygon base, okay? We're just going to phrase this with, and the lateral faces, that's the triangles on the side, right, are isosceles triangles. And that's what the definition of a regular pyramid is. Okay. Cylindrical tank below needs to be painted. The tank is open at the top and the bottom. Does not need to be painted. So we're only painting, right? You guys consider it. Get out of here, you. I don't even know why you're there. We're only going to paint, okay, just the sides of this thing, just the lateral part of this, right? We're only going to paint this part over here around the sides. All right, so the painted piece is actually just the surface area. Oh, get out of town, surface area. That includes the top and the bottom, right? So it's just the lateral area. Okay. So the lateral area is, formula is 2 pi r h. So 2 pi r, we know, is 12. All right, that's r. And there's my h. So 12 times 22. And I'll let you guys come up with that one. Now, each can of paint covers 600 square feet. So this is already in feet, which is good. So this is going to be feet squared. Okay. So whatever you get here, okay, whatever you get here, you're going to divide that amount by 600, and that's going to be the number of cans of paint. Remember that you cannot buy like a fraction of a can. So you're going to have to keep that in mind as you work along here. And then the surface area of this guy, and I'm going to let you guys kind of handle this on your own. What I will remind you is here, now I see where that came from. So we'll talk about it a little bit here. But what I want to remind you guys is that this side right here, this square piece, okay, right there, you cannot see this piece. This is on the inside of the figure, okay? So what we're looking at here is we're looking at this triangular, right, roof. We have this side, okay, we have the side that's over here, all right, and we have these triangles in the front and the back. We have those four sides. So there's no base, there's no like bottom part to this. So just be careful. So you're just doing those sides. And then we have the lateral area here, right? The area around the shape here, okay? And we can see the bottom. So there is one base on the bottom, all right? So just keep that in mind for yourself as you're working along here. Now, the thing we got to be careful with is this triangular face in the front, okay? We know that the distance from here to here is 5, okay? And we know that if we dropped a line straight down all the way to the bottom, it's going to cut all that in half. And so these are going to be essentially 7, all right? So when we drop the height for the triangle, okay, it's going to create this distance of 7 here. And so we're going to need to go figure out that length because we are going to need to figure out this, okay? Now remember, we know this is 9, so this piece right there is 9. What we don't know is, I don't know what this is. And that you're just going to use Pythagorean Theorem for. So 7 squared, okay, plus 5 squared is equal to c squared, and I'll let you guys go to work. It is going to be a radical, it's okay, just keep it as that, and then you're going to do the work from there. All right, guys, so that's for tomorrow, and I will see you guys on Wednesday.